Bismillahirrahmanirrahim. So, friends, in today's lecture, we will be talking about polymerization. So, it is not clear that why only molybdenum and tungsten oxoanions can polymerize. If we talk about chromium, the polymerization of its chromate ion stops at Cr2O7 2-. So, the question is that why polymerization of molybdenum and tungsten oxoanions takes place. As oxygen is an acceptor of electrons, when it accepts electrons, the size of anion increases. Accepting the electrons is an acidic property according to the Lewis concept. So, oxygen has a certain base strength. Also, the oxoanions like MoO4 2- and WO4 2- initially undergo protonation. So you can see that the oxoanions of molybdenum and tungsten undergo protonation, right? This protonation takes place by attachment of H positive ion to any one oxygen in molybdate or tungstate. This results in elongation of the bond because it changes from molybdenum oxygen or tungsten oxygen to molybdenum oxygen hydrogen or tungsten oxygen hydrogen, right? So here you can see that we have a molybdate, and here its protonation is taking place. So you can see that elongation takes place here between this molybdenum atom and this oxygen atom, right? So this is the figure of protonation of molybdate anion. The second reason is that elongation of bond which takes place after protonation is the reason for the protonated species uh, like MO3 OH minus to expand its coordination sphere by coordinating with water molecules. The size of metal ion is also important. When protonation occurs, it results in that particular molybdenum oxygen hydrogen bond getting weakened due to the elongation of the bond. This favors octahedral coordination. For larger metals, metal oxygen bond will be more ionic. So bonding overlap will be less favorable. That's obvious. That's why oxoanions of larger metals like uranium, niobium, tantalum can polymerize even in basic solution. Okay. Basic solution means whose pH is higher, right? While oxoanions of smaller metals like chromium, molybdenum, tungsten can polymerize only in acidic solution. Moreover, in acidic solution, bigger oxoanions of molybdenum and tungsten can polymerize more than that of smaller metal like chromium. All right. So now we will discuss the applications of polyacids. These acids have great solubility. They are used for the separation of solutions of high specific gravity. Number one. All right. Secondly, polyphosphoric acid is used for one step synthesis of certain cyclic compounds. This is the most important application. Heteropolyacids are used for detecting various alkaloids and albumin. They provide bigger source of synthesizing new and increasingly complex species. This is possible only by perfecting the existing methods and modifying them to meet new requirements. The anions show very low charge density on the surface and low basicities. Hexamolybdate ion and 12 tungstophosphate ion have even lower basicities than perchlorate ion, ClO4 minus. The heteropoly acids give rise to other compounds which have multiple oxidation state like tungsten and bronzes, which are brightly colored and used to impart different colors to metallic surfaces. Heteropolyblues afford large variety of shades of blue used in dyeing industry. All right. The recovery of some metals like vanadium, molybdenum, tungsten, uranium from their owns often involve formation of isopolyacids. These are used as starting materials for the manufacture of catalysts, especially for vapor phase oxidation and reduction. They are used in the preparation of pigments. Some polyacids are used for the detection of phosphates and arsenates. The heteropolyacids or their salts of phosphorus or these three are used in determination of some elements by volumetric, gravimetric, and calorimetric methods. So, friends, if we talk about inorganic polymers, so all the covalent macromolecules which do not have carbon in their backbones are called inorganic polymers. For example, covalently bonded crystals like oxides, halides, condensed phosphates, etc. Important similarity between inorganic and organic polymers is that both can be prepared by addition and condensation methods. If we talk about the classification of inorganic polymers, so first classification depending on whether the polymer contains the atoms of only one element or of different elements in its backbone. So first we have homoatomic polymers. These polymers contain the atoms of only one element in their backbones. For instance, sulfur has the tendency to form chains or rings like persulfides. Here you can see HSSH, HSSSH, hydrogen, sulfur, 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 hydrogen. So you can see that sulfur has the tendency to form chains, right? And secondly, the heteroatomic polymers are such polymers. These elements contain certain atoms of different elements in their backbones. So I hope that you have liked the lecture. For more important lectures, subscribe our channel What's Chemistry on YouTube and press the bell icon. Thank you.